of the Computing and Computational Sciences Directorate at Oak Ridge National Laboratory. And as you heard this morning, point person right now on the ECI initiative for us and for the Office of Science here. Doug's going to give us an update, a site update on what's going on at Oak Ridge. Doug, thank you so much.
And I have an hour and a half, is that right?
If you want. I think it's a full half hour. You can go 30 minutes. Blake, could you ask him?
Sorry?
Could you ask him to come up there? The PGA and it only takes 7 minutes. Right now it's
Okay.
Sound great?
Yes.
Excellent.
Okay. Can you hear me?
Do you want to use left or?
Well, I can stand. So I'm going to talk most about Oak Ridge, but I thought I would say one more thing about ECI. A slide I neglected to show this morning. And that's the fact that the project is going to be centered at Oak Ridge, meaning that will be where we'll hang our ECI project sign, so to speak. The leadership team will be from various DOE labs, but this is the latest organizational chart. And there you see the 4 principal technical areas: application development, software technology, hardware technology, xScale systems. There'll be a lot of project management and operations responsibilities that'll lie with Oak Ridge. And you see we have lots of ideas about what these councils might do with regard to ECI based on kind of past projects and programs. But I thought I would show that initially because it's a very exciting development for, I think, the DOE lab community in general, certainly for Oak Ridge, where we're going to get a chance to essentially stand up a new project office. And so there may be some shifting ahead, myself included, in the near future. So we have to talk more folks offline, but this is a slide that Steve Binkley showed in the July ASCAP meeting. So I neglected to show that this morning. So that's all I'm going to say about ECI, unless there are questions. But I'm going to move to an updates at Oak Ridge. So, and actually Chris Fuson is here, and maybe he can correct me if I say anything wrong, or from Oak Ridge. He sits at the Oak Ridge Leadership Computing Facility. And looking at past presentations from Oak Ridge folks, the last few meetings, I think you've seen some of this before, so I'll hurry through the material and get some new developments. So that's the Oak Ridge Leadership Computing Facility. Again, there are 2 leadership computing facilities for the DOE Oscar program, one in Argonne, one in Oak Ridge. So OLCF, as we call it. Organizationally in Oak Ridge, it sits within the directorate that I'm in, and it also looks like what we call a division as well. The And so key leaders that have been in front of this group, just to point out, Jim Hack is our division leader for the division known as NCCS, within which OLCF resides. Buddy Bland, who's been here a lot, I think most of you probably know, is the project director. Kathleen Baldwin is the deputy project director of OLCF. She's going to be moving over to the ECI project as our, I guess, lead project manager is how I would put it. And the OLCF just recently stood up a new group, data, I'm looking at Chris, Advanced Data and Workflow. Did I get that right? Yes. A data science group. In effect, we're seeing more and more applications and more need to have card-carrying data scientists, and we're standing up a new group. Jim Hack just announced this, in fact, today. So that's a new development for the OLCF, and it's just sort of recognition of what we're doing already as well as what we want to do moving forward. So I'm going to show some slides that Buddy Bland just put together. So again, as a reminder, since the leadership computing facilities were stood up in 2004, OLCF has really enjoyed a fairly rapid growth and rapid pace within the Oscar program with regard to systems. There you see kind of the history. I personally came to Oak Ridge in early 2006 when Jaguar was 23 teraflops. So seen myself and been a part of this center as well for 4 or 5 years. But I've seen myself the rapid growth, and in large part due to I think what we currently benefit from a lot of very talented leaders and managers as well as staff. So again, looking forward, I'm sure everyone's heard about and know a fair amount about Summit and the Coral arrangement, but I want to say a little bit about that and kind of what I see from my perspective. Currently, Titan is our system on the floor. It's the number 2 system in the world, at least from a impact perspective, which we may not necessarily like. But I'll say a little bit about Titan and kind of what's happening on that system, as well as where we are with Summit, and perhaps defer to some of my colleagues in the room here for details. Again, a reminder, Titan's still in full operation, and one thing that people may not appreciate or know is these centers go through fairly rigorous operational assessments every year, and the operational assessments are really conducted by an external group of users that gives very candid feedback on how the facility is operating. There are certainly a lot of metrics that are used for in this case, Titan, like system uptime, system availability, utilization. All that information is gathered and tracked carefully and used as a part of the assessment process. All the facilities, NERSC, OLCF, and ALCF go through this assessment. It really is a very good process. The point is, this last year's assessment really came back with some resounding, very positive feedback for the OLCF, and that's always been the case, but this year in particular was really nice, and be happy to share with you some of the information. Susie and others were a part of that. Anyway, there's the speeds and feeds. I'm not going to belabor those numbers, just to remind you. And I believe this group has heard about the Coral collaboration between Oak Ridge, Argonne, and Livermore. And from my perspective, this was not really necessarily a fortuitous arrangement, but all 3 labs really were looking at procurements in their various programs at the same time and came together. And there you see the approach and the benefits. And talking to Buddy Bland in particular, it's just been a great partnership that has really allowed, I think, the labs to work together more collaboratively, exchanging best practices, lessons learned, and maybe ways we should have been doing already. And other labs, Manny Neal's here from Los Alamos, so there's an Apex arrangement there. And so I think we're figuring out how we can work together and meet our own programmatic and institutional needs. So there you see the RFP requests, and Livermore issued the one RFP. From my perspective, Livermore does a very good job in the RFP process. They historically really have kind of taught the other labs how to go about that. So from an Oak Ridge perspective, we benefit a lot by learning from them. But in this case, the RFP being issued by Livermore made a lot of sense. They have really a lot of best practice approaches with regard to how this is done. So, two architectural paths chosen. Oak Ridge and Argonne actually chose different paths for very different reasons, and that's the Aurora and the Summit systems, and you probably heard about them, but I'll have a few slides here. So anyway, I'm not going to read all the points, other than that this collaboration has really worked well. And now what's occurring is on a quarterly basis, formal reviews are being held with the various vendors to see how things are coming with regard to their schedules. And certainly daily, if not weekly, conversations are going on. I think the Coral quarterly review, I'm looking at Susie, was just last week, the latest quarterly review. And so all three labs come together and basically hear how things are going or not going with regard to these procurements. Again, Summit and Aurora, the two systems really in the DOE Oscar space, the leadership computing facilities. You've probably seen this before. Essentially a hybrid node system with the Summit and the mini core system with regard to Aurora. And both of these systems have, depending upon funding, I think nice growth paths beyond their sort of initial targets. And I think I have the next few slides. So on the Titan system, again, we will continue our hybrid CPU, GPU architecture. From an application development point of view, there's a lot of very exciting things here. There's a lot of scary things here too. So we're going from about 19,000 nodes down to 3,400 nodes. Okay, so we're not really, nor have we been really, frankly, since I've been at Oak Ridge, our systems have all kind of been about 19,000 nodes. So we've just been beefing up the nodes. This is a major reduction. So we got 3,400 nodes, and now we got very essentially, there we go, 40 teraflops on a node, and kind of a teraflop and a half or so of memory. And so, the good old days, we heard that this, I think earlier today, of byte to flops being kind of 1-to-1. It's really not here. This node has a lot of very interesting aspects, but the memory to flop ratio is admittedly like sort of 3 to 5%. So there's going to be some challenges there with regard to trading off memory for compute. Like some of the other systems coming online, there's a lot of interesting potential with the NVRAM, ability to configure it for in different ways for different applications. Certainly, another example is the burst buffer at the Los Alamos Trinity system. From an applications perspective, this is not necessarily just extra memory, which is always nice, but they're sort of thinking about maybe equation state tables or data tables or doing out core things. In other words, I think each application has different ideas about what to do with the NVRAM and burst buffers. And this is an interesting, frankly, research area in terms of what makes the most sense from an application perspective. Let's see. The NVLink is a very promising development. We really like that. Really has helped, I think, potentially ameliorate what was before kind of a bottleneck. Summit compared to Titan, I believe that Cherrick Stratzman showed this the last HPC user forum when he talked about our car application. So I just thought it would be good to show this again, to give you the comparison of Summit and Titan. So we're seeing lots of really fairly dramatic changes with regard to the memory. And we're going to a different interconnect topology. I personally am very fond of a fat tree. Like to do a lot of implicit sort of computations in my own background, and fat trees are very helpful in that regard. If there are any questions, I'll just keep moving. The peak power consumption is really staying kind of right there. In large part due to the GPU certainly, but we've been able to keep that fairly constant at this time. Cherrick Stratzman heads our scientific computing group in the Oak Ridge Leadership Computing Facility, and I think he talked about this last time. Each of the facilities has what's called, I'll call it a science acceptance or early science program, whereby application teams can apply for early access on these systems and make the case for utilizing the system in a large way, in this case, in a more capability way. Also, in other words, what kinds of early science problems can we target? But also, what's my software path to get there, and where do I need help? And so this has actually become a very nice process over the last, fairly formal process over the last 4 or 5 years, where each facility has its own early science program that actually has real money behind it finally, meaning the DOE Oscar program typically commits one postdoc per application to partner with, it's another DEET application team that is selected, is able to hire a postdoc to come in and help them with these early science activities. And so the list of CAR applications, and again, CAR is the Center for Accelerated Application Readiness, was announced recently. I believe Cherrick announced this at the last meeting. And just to give you an idea of the breadth of codes and application areas, you can sort of view for yourself. A couple of interesting things to note. These selections aren't restricted to U.S. projects and to DOE mission space project only. The selections are made with approval concurrence by the DOE Oscar office, but you see some international representation. I'm guessing for the next round of this for Summit, you're going to see some other, maybe more what I'll call non-traditional apps, data analytics, data science sorts of applications. What we see here are more traditional HPC applications that are all going to deliver, we think, very impactful science, but I think you're going to see a different kind of mix of things moving forward. So in preparing for Summit, we're currently going through facility upgrades, and if you've ever come to Oak Ridge, it seems like this one road, I forgot the name of the road, Susie, is in a constant state of destruction. We're always putting new transformers and new bus bars and all kinds of things there. But currently preparing for Summit, and it will not sit in the same floor that the Titan sits. It'll sit nearby, occupy obviously a lot less floor space. But those facility upgrades are on schedule. And again, you talk to Buddy Bland if you have any questions, but we're already moving out in terms of preparation. The Insight program is still the major allocation program for these leadership computing facilities. There are about 60% of the core hours are allocated through the Insight program. And there you see the kind of ratio of requested versus awarded. I don't know what a good ratio is. If the request is less than what we can award, that's a problem. This is kind of 3 to 1. 10 to 1 may be bad. It may indicate we really are poor in our ability to service the user base. It could be good, and that more and more people have a need. But there you see the kind of the history. The Insight program for next year, I believe, is looking to allocate something like 6 billion core hours, and they're currently in the throes. Facilities work closely with in peer-reviewed subject matter expert committees in making these selections, and so they're currently, I think, in the process of finalizing those selections for 2016. As a reminder, these allocations are typically multi-year with sort of year renewable, meaning if you don't use any hours, you're likely to not get your second year, okay? So that's probably the first order metric. These allocation cycles tend to be sort of 3 to 5 years. I'm looking at Susie to make sure I got that. Yeah, I got that right. One other point is, as we move into exascale and we look at a broader array of applications, it very well could be that the Insight program will change and adapt accordingly. There are certain sets of requirements and targets that the Insight program is looking for, and I'm speaking as Doug, not Oak Ridge, okay? I've had discussions with DOE Oscar program about potentially looking at the Insight program and rethinking a little bit with regard to the allocation process, given that I think we're going to have a kind of interesting different spectrum of applications. So that's something. The Insight program has been very, very successful. I think it's a model. I think the PRACE program follows a lot of this. In fact, I help review a lot of the PRACE projects, so I get a good sense of what that program looks like. I think the Insight program is really been a model in that regard. So I'm not suggesting it needs to change in a major way, but I think it needs to sort of adapt as technologies and application needs change. And Susie is a big part of this program, the Excel program. I just wanted to put in a plug that we have seen more and more industry usage and more industry feedback, return on investment, so to speak, on type. And in fact, the industry projects continue to grow year by year. And Susie's probably briefed you all on this, but it's really, I think, it's being seen, at least across the DOE lab complexes, that either have user facilities or want to move in that direction. This program is seen as a model, and other labs are very interested in emulating it. So we're very likely going to, now speaking with my ECI hat on, pull Susie into that gig and have her figure out the how to best work more closely with industry. So we're lucky to have her right here. In terms of some science output, I'll just say a few things. One could look at the applications in various spaces like geosciences, energy, and fundamental sciences. Certainly one of our poster apps on the OLCF is climate, and in this case, the relatively new DOE ACME program, which is taking the CSM model kind of into the future. There's a lot of energy production, energy transmission, energy generation sorts of applications. And the last 5 years, I've been working myself on a project known as CASTLE, which is about modeling nuclear reactors, and so that would fit in that middle column. And of course, there's a lot of fundamental science here as well. And so Buddy did a nice job at sort of piecing together the various applications. And I'm not going to go into any of the details here, other than to say that there is a fairly broad spectrum of energy generation applications represented right now on the Titan system. And I think we're going to see those grow, and both in breadth and depth. Certainly, as we look at the exascale possibilities, every one of these areas has made, I think, a pretty good case for application development and delivery of solutions on the exascale systems. And then on the transportation side, this is where I think we're going to see more and more growth, in particular on the manufacturing side. I've been looking at that, and I think there's a real need and interest to be able to simulate, to develop high fidelity simulation tools for additive manufacturing. And so I think we're going to see some interesting new applications in that space. And certainly we're seeing more and more related to energy storage. The battery hub is a good example at Argonne. And so I think on the transportation side, there's some interesting possibilities. And these are currently existing applications. I will say that we've been talking some with the ERE Vehicle Technologies Office, and I think something like an integrated virtual car application is quite possible and very interesting as another area to focus on moving forward. And again, climate science, grid, superconductivity, or strongly correlated materials have a big presence on our system. Carbon capture and storage, in particular the CCSI, Carbon Capture Storage Initiative at NETL, has a nice simulation package that I think is going to be continue to be a consumer of resources at Titan and other sites. Let me talk in particular about a fairly new development, and that's something we call CADES. And there you see it's actually a destination in the Smokies, Cades Cove. And I guess I'll credit my boss, Jeff Nichols, maybe for coming up with that name, but it's got a nice geographical representation in our neck of the woods, as well as an acronym. And so this has been an ongoing activity, a new data center, if you will, for a couple of years. And right now, the focus is more internally in providing an environment, an ecosystem for Oak Ridge staff to do data science and data analytics. Arjun Shankar is the center lead. We do envision CADES as growing and becoming more of an integral part of the DOE Oscar program and maybe more integrally part of the OLCF with regard to what we think will be happening in the future, namely something like a science data facility, or SDF as Steve Binkley calls it. We see something like that as quite possible. And so CADES has been an ongoing effort for a couple of years, and it continues to grow. I want to say a little bit about CADES. I encourage, if you're interested, I can give you this CADES director, Arjun's contact information. So the CADES mission is really, initially, it was more about the infrastructure needed to do this kind of science, okay? But it's really growing to where the center itself would like to, in partnership with the OLCF, really provide data science solutions. So have data science staff, as well as the technologies, being hardware and software, in one ecosystem. And so this is the current mission for CADES. And the idea here is to stand up an array of flexible toolkits and services. And many of these did not really exist at Oak Ridge a few years ago. I have another slide that gives you examples of the technologies. But CADES right now is partnering with some of the data experimental facilities at Oak Ridge, Spallation Neutron Source as an example, the Center for Nanomaterials, in understanding their imaging needs, their data needs, and using this technology and the toolkits and the ecosystems as well as the staff to help some of the projects internally. So it's been more internal looking to date, but we see it expanding and moving out externally later in the next few years. So some of the CADES systems on the floor, I'll let you look at that. But for example, we have a Eureka system for graph reduce, the Hadoop systems, and we're looking at the OIC. I'll just point out at the very bottom. That's a sort of an Oak Ridge term for institutional computing, meaning we provide a lot of compute services in our directorate for smaller scale cluster capacity sorts of resources. And that's from an institutional investment. CADES will subsume all that, and all the sort of local institutional computing will be part of CADES, but we're going to have the data science and data analytics software and hardware all part of the same system, okay? And having it be able to integrate with and talk with Titan and the OLCF is also instrumental. So that's an idea of kind of where we are now, and this ecosystem is growing by leaps and bounds, frankly, every year. So here you see kind of an idea. This is sort of the way CADES is currently operating within Oak Ridge. Namely, you see SNS projects, ARM projects, active projects, CNMS projects, CASTLE, the program I used to run. These are principally Oak Ridge or Oak Ridge collaborative projects. So CADES is first working locally, kind of understand what the center can do to help data science needs locally, and then we're working to expand and look more external as well. So it's a fairly heavy laboratory investment in this center, as well as projects. In the one I was involved in, CASTLE, invested in CADES in either infrastructure or staff or both. So it's really viewed as a birthright model. If you're an Oak Ridge staff, you have access to this data center or this data science center, as well as projects are encouraged to collaborate either in funded or non-funded ways. So this CADES is still evolving, but I wanted to expose you to this group, get your thoughts and feedback. We certainly have been talking with our DOE sponsors about what we want to do and why, and feel like we'll be the center will enjoy some growing support in the future from more and more DOE sponsorship. And examples of current partners for CADES, and you see that Arjun Shankar and his people have reached out not only internally but also externally, begin to interact with external customers and stakeholders. With that said, I believe I'm done. So if there are any questions or comments, I'd be happy to take.
Doug, just had a question. I understand you have a good relationship with the University of Tennessee as well. This is a total side question related to our NSCI discussions earlier.
Do you have, do you have programs or relationships where you can dedicate some resources for the undergrad engineers or data science or something? Is that something you guys have going on?
Yes, and that would likely occur